Remember, we said there were 4 quantum numbers, and the last quantum number is known as the spin quantum number. If you look back and look at electronic configurations, how you've learned them, if you think about it, every orbital has 2 electrons in it. For example, s orbital, 2 electrons in it. P orbital, there are 3 p orbitals, each of them with 2 electrons each in it. Total of 6, 2 electrons, 2 electrons and 2 electrons. So when we say each orbital has 2 electrons in it, one of them rotates in the clockwise direction, the other one rotates in the counterclockwise or anti-clockwise direction. So there are 2 electrons in each orbital, each single individual orbital, one of them in the clockwise direction, the other one rotates in the anti-clockwise or counterclockwise direction. So when we represent orbitals as squares, S is represented as single square, P is represented as a combination of 3 squares, because remember it comes as a set of 3 orbitals, and D is represented as a combination of 5 orbitals, and we write the 2 electrons as one with the clockwise orientation, other one with the counterclockwise orientation. So first, when you have orbitals of the same energy, all of the piece will be filled clockwise, then pairing up of electrons starts. So one with the counterclockwise and the other one with the clockwise direction. So if we had a configuration, for example, 1s2, 2s2, 2p4, for example, this is configuration for oxygen. So if you were to represent this as boxes, two s, 2 electrons, and 2p represented as a combination of 3. So clockwise, completely filled. So the set gets half filled first, and then pairing up starts. Okay, so there are 4 electrons in this orbital. So as far as magnetic quantum number goes, if the electron is oriented in the clockwise direction, the spin quantum number is referred to as positive half. And if it is oriented in the counterclockwise direction, then the spin quantum number is oriented as negative half. We will work on problems in class about what kind of questions they will ask you on quantum numbers.